a lot of times you're going to want to see what's going on with the circuit. It's easy to understand what's going on when you're looking at a simulator because you see things that you normally wouldn't see with your naked eye. So we've got a really important tool in electronics called an oscilloscope. And the way the oscilloscope works is it lets us see things that we normally wouldn't, because it's going too fast, it's too small. All it does really is measure voltages through time, and it'll display that, and we can learn stuff about what's going on in a circuit. So let's look at ours. All right, so I'm going to try to make this general purpose so that we can use it no matter what. I'll make separate videos for when you're using it for different things, but I want one video that you can reference for the oscilloscope that we have. Now, you may be watching this in 100 years because it's so good that people keep putting it up after I'm dead, and y'all might have much better oscilloscopes. So if that's the case, this might not pertain to you, but one of the key things that you need to learn is how to find information. So if I'm reaching you and you do not have one of these oscopes, the best thing that you can do is look up your oscope, get the manual, read it, watch a video on it, and get to know it. So this is really an oscope introduction for the Tektronix TBS 1052B that I have right here. But most of the stuff will be applicable for anything that you use. All right. So on this particular one, there's a button up here. You push it. It's an electronic oscope, so it's going to take a little bit of time for its firmware to boot up. This has two channels, and they're going to be represented by yellow and blue. So we'll have a yellow signal and a blue signal up here, and we can tell what's doing what by those two colors. Right now, I don't have my leads hooked up to anything, so it's not really showing anything. You'll take a lead. A lead has a little clip that you can clip onto parts of a circuit, and then you've got a alligator clip that you can hook up to parts of a circuit. Keep polarity going in the right direction. Hook up the alligator part to what you'd consider ground if you have one. So if you're referencing ground, that's where you would. But whatever the more negative side of the signal, I would hook up there. All right. So you've got a B and C connector that is going to plug in here. All right. So now we've got the yellow channel that can work. If you're only doing one thing, you can turn on and off the channels by clicking that button. So we've got a yellow and a blue, but we don't have a blue plugged in. That's fine. We'll plug in the blue. At the least, I usually do at least two channels because I like to pay attention to the input. Okay? So first thing you want to do until you get used to using the oscope, plug it into a generator. Okay? So we've got a signal generator that's putting out a signal. I don't have a clue what it is, but on the red lead, I'm going to connect. And on the black lead, I'm going to push out. I'm going to connect it to my black lead there. So now my blue line is going straight across because it doesn't have anything going on with it. And my yellow line is now alternating because I have a sine wave at a certain frequency. Okay. Now if I turn that frequency up, I can see that my sine wave is happening more times per second. Okay, I turn it back down. Now my sine wave is going slower. Okay. Now, when you set your signal generator to whatever frequency you need it to be, don't change this to get this the signal looking like you want it to. So I can go in, especially if you have an old function generator that's not really showing what frequency you're doing. Now, we've got a couple of multipliers, which makes it so that as I turn this frequency up, like it's going from 0 to, multiply by 100, whatever it is. But I can't really tell what that is by this screen, and it's not calibrated. So first thing you want to do is, while you're playing with this, use this, because this is calibrated, to get it to the frequency that you want. Okay. So down here on this screen, I've got 12.83 hertz. Okay. Now, you're not going to be able to get real resolute with this knob. So if we say do 12 kilohertz, so we'll move it up till we get to 12k hertz. So we're going to have to move it up. We're at 207 hertz. Now we're going to move the multiplier. All right, so we're at 2.1 kilohertz. All right. So if I tell you to set it to something, you need a roundabout. I'm not going to be able to get it right at 2000 hertz, I don't think. I can get it pretty close. All right, so I'm at 1.9. So I've got it. Now, since it's going so fast, I'm not able to really tell anything about that circuit. Okay? So there's two knobs that you really need to pay attention to. The knob on the channel right here is going to make the signal bigger. So if this was a small signal that I couldn't see, I can use this to zoom in on how to make the signal bigger. Okay? So the knob, the big knob on the channel, is changing the amplitude or the multiplication so that we can see really small signals. Okay? If I had a really big signal, I'm going to want to turn that down so that I get all of the information on the screen. Okay? It's just going to take some playing with to get used to. Alright, the other knob is this right here, which is your horizontal scale. Vertical represents a voltage going up and down. Horizontal represents how fast we're sampling that information. So if we turn that down, or up, depending on what we want, right? We can get a better representation of our signal. Now, by changing this, I did not change that to 2 kilohertz. I want to go to 2.1, but whatever. All right, so let's go to 2K. Make sure that we can get a good sine wave. There's no way of seeing that with the naked eye. It's like 4 millivolts. If I push this, if I tell you to use a triangle wave, I don't need to change this because the voltage stays the same. I need to change this horizontal. Until I get a good signal. Okay? Usually you want to get, 1 or 2 good looks at that. So you're zooming in on time. You're you're looking at a faster signal, so I'm going to have to scale it so that I can look at it. So this knob is going to be representing how quickly. So if we need to spread that out, if it looks like garbage, we can't tell anything about it, but we've got good up and down, this is the knob that we're going to use. Okay? Now, when I add in the second channel, I can adjust this too for different voltages. I can even turn it up enough that it's actually seeing the noise that's in the air, right? So if I ground out that clip, it should go out. But even having that out, I zoomed in far enough that like you're seeing stray capacitance from my hand and such, and electrical noise from the room. Okay? So I've got this. I'm going to turn it back down because as soon as I like make a connection here, I'm going to do it backwards so that we have an inverted signal. I want to scale it. Actually, I grounded that out. Ignore that part. So what I want you to do instead is take the blue lead after you connect. The way you put the BNC in is there's two little nubs right there. You slide it in and then you turn the collar until it latches in. So now I'm going to take the blue and I'm going to hook it up. And I'm going to get back to a good wave. All right. Now it's running across because we're not syncing it up or anything. We're actually syncing up with the yellow one. But we've got a pretty good representation of our signal. So if we go back to the yellow, the big difference here is we've got yellow, like the first channel synced up so that it's the thing that is saying this is a beat, this is a beat. So it's not running around like the blue one will if the blue one's by itself. If I hook this up so I'm not shorting it out like I did before, the blue one will be synced up because the yellow one's synced up and we're using the same signal source. And now you see that both signals are equal. All right. Now, set both of them so that they're up and down equal. Like I can adjust this so that I'm not zoomed in as much on the blue. And I can move it. Like so the little knobs up top, move that signal so that if they're right on top of each other, you can still see it. Okay? You don't want to do that too much because you might want to do that to see the signal and then you want to put it back down where it was so that when you're comparing signals, you know what they're doing. Okay? So now that you've set your oscilloscope up for the signal that I told you to, ignore this. Like, use this to set your signal because this is a lot more resolute. All right. Now I can change to a square wave. I can change to a triangle wave. I can change to a sine wave. I can adjust the frequency here, but at that point, I'm not really changing what I'm doing with any of the stuff here. So use it to set up your signal generator and then leave that alone. Okay? And then you can use these to get it so that you recognize the signal, and then you'll use this information to do some labs where you're going to need to see what you're doing inside of that circuit, and the only way of doing that is an oscilloscope. Okay? When you're done, you'll turn it off, take the leads off, wrap them up loosely so that they're just not a mess, and just, do whatever the teacher tells you to with it. All right. Here, there's a drawer for them. All right. That's Oscilloscope Basics.